So welcome. This is a video based upon 3D geometry. So we have three dimensionals over here, x1, y1 and z1. Similarly, the other point is x2, y2 and z2. Now it's going to be the same formula as far as this 2D dimensional is concerned. So we are going to find it out, the answers for that. The first question, find the distance. So distance is going to be square root of x2 minus x1 whole square. So it becomes 2 minus of minus 1 whole square plus y2 minus y1 whole square, negative 3, negative 1 whole square plus z2 minus z1 whole square, 5 minus 5 whole square. Simplify that. Directly I'm writing that answer. You should be able to get 5. Distance between O and B. Origin is 0, 0, 0. The third dimension is asked and B is negative 1, 1, 5. So the distance is going to be square root of negative 1, negative 0 whole square plus 1 minus 0 whole square plus 5 minus 0 whole square. Simplify that. You should be getting square root 27, which is 3 root 3. Now the coordinates of the midpoint. It's the same formula. So what is that formula? x1 plus x2 upon 2 comma y1 plus y2 upon 2, but here the third coordinate is there, so z1 plus z2 upon 2. So when I'm going to add that and divide them, so it becomes 2 minus 1 upon 2 comma minus 3 plus 1 upon 2 comma 5 plus 5 upon 2. So what does becomes? It becomes 1 upon 2 comma 1 negative 1 comma 5. Then the coordinates of point C, given that B is the midpoint of AC. So this is A, C, B is the midpoint. So what is A? 2 minus 3, 5. And B is minus 1, 1, 5. And C is X, Y, Z. So X plus 2 upon 2 should be equals to negative 1. So X plus 2 equals to negative 2. So X equals to negative 4. Then y minus 3 upon 2 equals to 1. Y minus 3 equals to 2. So y equals to 5. Then z plus 5 upon 2 equals to 5. So z plus 5 equals to 10. So z equals to 5. So what is the point? Negative 4, comma 5, comma 5. Now come to question number 2. In the question number 2, these are solid 3-dimensional solid figures have been given. We are supposed to find it out the volume, area, and the other things of these questions. So how should I be able to find them? So volume is length times breadth times height. So which is 5 times 3 times 4, which is going to be 60. Surface area is 2lb plus 2bh plus 2lh. So which is 2 times of 15 plus 2 times of 12 plus 2 times of 20, which is going to be 94. Now for a cylinder, radius is 2 and height is 5. So volume formula is pi r square h. So which is pi times 2 square times 5. So which is 20 pi. And surface area, which is 2 pi rh plus 2 pi r square. So which is going to be 2 pi, radius is 2 times 5 plus 2 pi times 2 square. Simplify that, 28 pi. Cone, radius is 3, height is 4. So volume is 1 upon 3 pi r square h. So it is going to be 1 upon 3 pi times 3 square times 4, which simplify 12 pi. Surface area. Now, first of all, I have to find slant height. Slant height is square root of h square plus r square, which is 3 square plus 4 square, which is going to be 5. So surface area is pi rl plus pi r square. So it's going to be pi times 3 times 5 plus pi times 3 square, which is going to be 24 pi. Now sphere volume 4 upon 3 pi r cube. So which is 4 upon 3 pi times 3 cube, which is going to be 36 pi. Now surface area 4 pi r square, so which is 4 pi 3 square, which is 36 pi. Question number 3. The right pyramid square base of side 8 and vertical height 3. Find the volume. Volume is 1 upon 3 base area times height. Base area times height. So 1 upon 3 base area is 8 square, height is 3. Simplify that, 64. The surface area. So I have to calculate the surface area over there. So what am I going to do? I am going to consider the right angle triangle over here. AMN is a right angle triangle. So hypotenuse square equals to sum of squares of other two sides. So AM equals to nothing but what? 5. So I got AM value as 5. Now the surface area, there is surface area, area of the base plus 4 times area of the triangle. So area of the base is 8 square plus 4 times area of a triangle, half times base is 8, height just now we have calculated it was 5. Simplify that, you should be getting it out the answer as 64 plus 80, which is 144. Question number 4. Sine B. Sine B, opposite side upon hypotenuse 4 upon 5, cos B 3 upon 5, tan B 4 upon 3. Sine C 3 upon 5, cos C 4 upon 5, tan C 3 upon 4. Sine is opposite side upon hypotenuse, cosine is adjacent side upon hypotenuse, tan is opposite side upon adjacent side. Confirm that the sine rule holds. It is known that sine A equals to 1. So A upon sine A equals to 5 upon 1, which is 5. So B upon sine B, B is 4 upon sine B, 4 upon 5, which is equals to 5. So we are going to get the same answer. C upon sine C, C is 3, sine C is 3 upon 5, that is 5. Confirm that all three versions of the cosine rule holds good. So 5 square equals to 3 square plus 4 square minus 2 times 3 times cos A. So we got it out, 25. Same is the case. Other two sides are 4 and 5. 4 square plus 5 square minus 2 times 4 times 5 times cosine C. Cosine C is nothing but how much? 4 upon 5. When you simplify it out, you will be getting it out 16 plus 25 minus 32, which is going to be 9. Next, 4 square, which is going to be 3 square plus 5 square minus 2 times 3 times 5 times cosine B. Cosine B is nothing but how much? 3 upon 5, which is going to be 9 plus 25 minus 18, which is going to be 16. Next, part D, he's asking us to find the area of a triangle. So half AB sine C, it can also be written as half AB sine C or half BC sine A or half AC sine B. So already he has used it as AB sine C. BC sine A has been used, so I'm going to use it out half AB sine C. So half times 4 times 5 times sine C. Sine C is 3 upon 5. When you simplify, this becomes 6. Then half times, I'm going to use it out, sine B. 3 times 5 times sine B. Sine B is nothing but what? 4 upon 5, which is going to be nothing but what? 6. Next, question number 5. Use the cosine rule to find the side of side A. So A square equals to 10 square plus 8 square minus 2 times 10 times 8 times cosine 60. So which becomes A square equals to 84. So A equals to square root of 84, which is approximately 9.17. Now question number 6. In question number 6 also is asking us to use cosine rule. So always the cosine rule is going to be the most easiest one. So whenever there is no matching pair, we are going to use the cosine rule. Over here we can clearly see that there is no matching pair for that question. So therefore I am going to use cosine rule. So for that cosine rule, question number 9, 9 square equals to 10 square plus 8 square minus 2 times 10 times 8 times cosine A. So cosine A equals to 83 upon 160. This gives you A equals to cos inverse of 83 upon 160, which is 58.8 degrees. Question number 7. Use the sine rule. Whenever there is a matching pair, we are going to use sine rule. So question number 7, A upon sine 45 equals to 10 upon sine 30. So A equals to 10 times sine 45 divided by sine 30. Simplify that. 10 times root 2 upon 2 divided by 1 upon 2, which is 10 root 2. Next question number 8. Use the sine rule to find the sine of the angle. So 10 upon sine A equals to 6 upon sine 30, which makes sine A equals to 10 sine 30 upon 6, which is equals to nothing but what? 5 upon 6. So which is A equals to 56.4 degrees. So another angle will be 180 minus, take the total calculated display 56.442, which is going to be 123.557. Round it off, it should be equals to 124. Question number 9. Point A is at the center of the following diagram. Bill and Chris and Diana are located at a point A and start moving. Bill is northeast to the point B. Bill is northeast to the point B. So Bill is over here. Chris is the south of the point at the point C. So Chris is over here at the point C. And Diana to the west of the D. So Diana is to the west at a point D. So I can take D over here at the west. So write down the angle BAC. So what is BAC first of all? Where is B? This is B. This is C and west of D. So I will change D over here. So D I change it out to over here. Now he is asking BAC. So I join that one triangle and it forms. So BAC is how much? So we know that when I see that this angle is 90 and this angle is 45. So total it will be 90 plus 45. So part A, it's going to be 90 plus 45 degrees, which is going to be 135 degrees. Write down the bearing of the course of each person. So bearing of B from A. So I'm going to do bearing of B from A, C from A, D from A. So what is the meaning of bearing? Bearing of B from A. So what is the meaning? Go from the north direction and move in the clockwise direction. So I'm moving it out over here. So when I'm moving, this is the north, and I'm moving, I get 45. So B, I'll be reaching it at 45. Whereas to reach C, this is 90 and another 90. 90 plus 90, 180. So for C, it is 180. Whereas for D, again start, this is 90, then this is another 90, and then I reach D, which is another 90. So 90 plus 90 plus 90 is 270. So once again, for reaching B, it is 45. For reaching C, it is 180. And for reaching D, it is 270. So answer is going to be 45, 180, and 270. Write down the bearing, find the bearing of from B to A, from B to A. So this time I'm starting from B. So this is B, that's 9. Then I should reach A, 90, 180, then another 45. So 180 plus 45. So see clearly. So what is that happening over there? So from B, draw a north line, then move it and try to reach A. So this is 90. I have not reached A. This is 180. I have not reached A, but this is 180 plus 45. I can reach A. So therefore it is 180 plus 45. So once again 90, 180 and 180 plus 45 will make me to reach A. So therefore it's going to be 180 plus 45, which is 225 degrees. Given that AB is 2 kilometers and AC is 3 kilometers, find the distance between B and C. AB is 2 kilometers and AC is 3 kilometers. Find the distance between B and C. So I'm going to use cosine rule. So BC square equals to 2 square plus 3 square minus 2 times 3 times 2 times cosine. What is the angle between that one? We have already learned the angle was 135. So cosine 135. So simplify that. You should be getting 4.6352, which is 4.64. Question number 10. Find the length of AC. AC is the diagonal for the down triangle 5 and 3. So AC equals to square root of 5 square plus 3 square, which is square root of 34. Find AD. AD is the diagonal of the room. We can call it as the diagonal of the total figure. So AD will be equals to square root of 5 square plus 3 square plus 4 square, which is going to be square root 50. Find the angle of elevation of A to E. So A to E. So this is going to be a right angle triangle. Opposite side is 4, adjacent side is 3. So I'm going to use tan. Tan EAB equals to 4 upon 5. It implies EAB equals to 38.7 degrees. Then find the angle of elevation of A to D. So for A to D, this is a right angle triangle. The blue color one is going to be a right angle triangle. Opposite side is 4, adjacent side is AC. So tan DAC. DAC equals to, opposite side is 4, adjacent side is root 34. So it implies DAC equals to tan inverse 4 upon root 34, which is 34.4. Then angle of depression from E to A. Angle of depression from angle of elevation from A to E will be same as angle of depression from E to A. So it's going to be the same 38.7 degrees. This is part C, part D, and part E. When we are looking, the angle of elevation from A to E will be same as angle of depression from E to A. Basically, angle of depression means this angle, this color, green color angle. It will be same as this angle. because they are parallel lines, alternate angles will be the same. Question number 11. In each of the following triangles, one of the angle size is 40, two sides have 5 and 7. Find the for the following triangle, find the area. Area is 1 upon 2 times 5 times 7 times sine 40. Simplify that, you should be getting 11.2. Find BC. So BC square equals to square root of 5 square plus 7 square minus 2 times 5 times 7 times cosine 40, which is equals to 4.51. Find the size of angle B, hence find the angle C. So for finding B, I use sine rule. Sine 40 upon 4.51 equals to sine B upon 5. This gives me, directly I'm writing the answer, B value is 45.4 degrees. So angle C will be 180 minus 40 minus 45.4, which is going to be 94.6 degrees. Question number B. For the following triangles, find the size of angle B and hence find the size of angle A. So over there, what am I going to do that? Sine 40 upon 7 equals to sine B upon 5. So this gives me sine B equals to 5 times sine 40 divided by 7. So from here, I will be getting the value of B as 27.3 degrees. So A will be 180 minus 40 minus 27.3, which is 112.7 degrees. Question number C. For each of the following triangles, find the size of C and hence the size of A. So we can see that sine 40 upon 5 equals to sine C upon 7. So sine C equals to 7 times sine 40 divided by 5. So from here, I will be getting the value of C is 64.1. If C is 64.1, A will be 180 minus 40 minus 64.1, which is 75.9. In the other case, 5 upon sine 40 equals to 7 upon sine C. From here, I get sine C equals to 7 times sine 40 divided by 5. From here, I get the value of C as 115.9. So A will be 180 minus 115.9 minus 40, which gives me 24.1. Question D. For the following triangle, use the cosine rule to find the value of BC. So I should be able to find the value of BC. So, but we know the angle opposite to 40, what is a 7. So therefore, I'm going to use 7 square equals to 6 square. 7 square equals to, let us consider this as 6 for a moment. We try to change this one to 6. 7 square equals to 6 square plus BC square minus 2 times 6 times BC times cosine 40. So what am I going to get it out? Let BC equals to x. So I get a quadratic. X square plus 36 minus 12x cosine 40 minus 49 equals to 0. You can use a GDC and get the value of x from here. So BC value, you will be getting it as 10.437, which is approximately equals to 10.4. Once I got the BC value as 10.4, area of the triangle is going to be 1 upon 2 times 6 times 10.437 full calculator display times sine 40. So simplify that, 20.126, which is 20.1. Question number E. For the following triangles, use the cosine rule to find the value of BC. So for this also, we are going to consider this side as 6. So 6 square equals to 7 square plus BC square minus 2 times 7 times BC times cosine 40. Use the GDC, you will be getting it out 1.3931, which is equals to 1.39. And in that case, in the next case, it is going to be, I'm going to find it out in the same way. BC is 1.39 over there. And in the next case also, we are going to get the same thing. Quadratic, two equations, the shorter one and the longer one, because quadratic has two answers. So one is 1.39 and the another answer is 9.3314, which is approximately equals to 9.33. Because it's a quadratic equation, you get two answers. Now in that case, area is going to be 1 upon 2 times 7 times 1.3931 total calculated display times sine 40. Sine 40, simplify that, you should be getting 3.13. In this case, area should be equals to 1 upon 2 times 7 times 9.3314 and so on times sine 40. Simplify that, you should be getting 21.0. Question number 12. The diagram shows the triangle ABC. AB is 7, BC is 9, angle ABC is 120. Find AC. So AC square equals to 7 square plus 9 square minus 2 times 7 times 9 times cosine 120. From this, I'll be getting the value of AC as 13.9. Find angle BAC. Use sine rule. Sine A upon 9 equals to sine 120 divided by 13.9. From here, I get the value of A as 34.1 degree. Question number 13. A triangle has a side 4, 5, 7. Find the nearest tenth of a degree, the angle of the largest angle. Largest angle will be opposite to largest side. Largest angle will be opposite to largest side. So cos alpha equals to 4 square plus 5 square minus 7 square upon 2 times 4 times 5, which is going to be negative 1 upon 5 from here. So alpha equals to 101.5 degrees. Question number 14. Find the size of the smallest angle. Will be opposite to the smallest side. So 5 square should be subtracted. So cosine theta should be equals to 8 square plus 7 square minus 5 square divided by 2 times 8 times 7. So theta equals to 0.7857 cos theta. So theta equals to 38.2 degrees. Hence find the area of the triangle. Area equals to 1 upon 2 times 8 times 7 times sine 38.2. Simplify that, 17.3 centimeters square. Question number 15. Find the size of the angle PQR. So I'm going to draw a triangle PQR. PQ is 6, QR is 4, PR is 5. PQR means this angle opposite side is 5, so you have to subtract 5 over there. So 5 square equals to 4 square plus 6 square minus 2 times 4 times 6 times cos of Q. From here, I'll be getting the value of Q as 55.8 degrees. Find the area of the triangle. So area equals to 1 upon 2 times 4 times 6 times sine of 55.8. So which is going to be 9.92 centimeters square. Question number 16. Find AB. So this angle will be 80 degrees because sum of all angles is 180. So AB upon sine 40 equals to 5 upon sine 80. So this gives me cross multiplication. AB equals to 3.26 centimeters. Find the area of the triangle. So once I know area equals to 1 upon 2 times 5 times 3.26 times sine 60, which is going to be 7.07 centimeters square. Question number 17. Find angle PRQ. So I'm going to use sine rule. Sine r upon 7 equals to sine 75 upon 10. From here, r value is 42.5 degrees. So what will be angle P? 180 minus 75 minus 42.5, which is 62.5. So area of a triangle will be 1 upon 2 times 7 times 10 times sine 62.5. Simplify that, 31.0 centimeters square. Question number 18. In triangle ABC, AB, BC, angle A are given. Find angle B, correct to the nearest degree. Sine B upon 5 equals to sine 48 upon 7. This gives me sine B equals to 5 upon 7 times sine 48. So this gives me sine B equals to 0.5308. So B equals to 32.06. So nearest degree is 32 degrees. Question number 19. The diagram below shows two triangles, both satisfying the conditions. AB is 20, AC is 17. Angle ABC is 50 degrees. This angle is 50. Find the size of the angle ACB in triangle 2 and area of the triangle 1. So sine ACB upon 20 equals to sine 50 upon 17. From here, sine ACB equals to 20 times sine 50 upon 17, which is going to be 0.901. So ACB angle will be equals to 64.3 degrees, or 180 minus 64.3, 115.7 degrees. So now we know that angle ACB in part A, in second triangle, angle ACB is greater than 90 degrees. So therefore, I am going to take angle ACB as 116 degrees. Now, that is part A. Whereas in part B, in triangle 1, this is going to be angle ACB in this one triangle. Angle ACB equals to, which is less than 90 degrees, 64.3. So angle BAC will be 180 minus 64.3 minus 50, which is going to be 65.7. So what will be the area? Area is 1 upon 2 times 20 times 17 times sine of 65.7, which is going to be 155 centimeters square. Question number 20. Given that town B is 56 kilometers from C, find the angle of what is this? Town B is 56 kilometers from C. So this is 56. So find the angle CAB. So cosine CAB equals to 48 square plus 32 square minus 56 square divided by 2 times 48 times 32, which gives me approximately CAB equals to 86 degrees. Question number 21. Two boats A and B start moving from the same point P. Boat A moves in a straight line 20 kilometers per hour. The boat B moves in a straight line 32 kilometers per hour. The angle between the two paths is 70 degrees. Find the distance between the two boats after 2.5 hours. So this is going to be the triangle. So this is point B, A, B. This angle is 70 degrees. After 2.5 hours, 2.5 times 20 is 50. 2.5 times 32 is 80. So he's asking us to find D. 2.5 times 20 is 50 and 2.5 times 30 is going to be 32, is going to be 80. So I'm going to find AB. So D square equals to 50 square plus 80 square minus 2 times 50 times 80 times cosine 70. This gives me the value of D as 78.5 kilometers. That's going to be the answer. Question number 22. Find angle C is obtuse. So, and area is 20. Find angle ACB and AB. So, area is 20. So, 1 upon 2 times 5 times 13.6 times sine C equals to 20. So, from here, I'll be getting sine C equals to 0.5882 and so on. So, C equals to 144 degrees. Because it is obtuse, I take an angle greater than 90 degrees. Now find AB. So AB equals to square root of 5 square plus 13.6 square minus 2 times 5 times 13.6 times sine 143.968 and so on. Take the full calculator display. Simplify that, you should be getting 17.9. Question number 23. Triangle ABC. This is triangle ABC. AB is 4, AC is 3, area is 4.5. Find the two possible values of angle BAC. So 1 upon 2 times 3 times 4 times sine A equals to 4.5. So sine A equals to 0.75. So from here A value will be either 48.6 or 180 minus 48.6, which is 131. Then question number 24. Triangle PQR. PQR. PQ is 10, QR is 8. Find area of the triangle is 20. Find the size of the angle PQR. So 20 equals to 1 upon 2 times 10 times 8 times sine Q. Sine Q equals to 0.5. So Q equals to 30 degrees. Question number 25. There is a vertical tower TA of height 36 centimeters at the base A of a hill. The straight path goes up the hill from A to a point U. This information is represented by the following diagram. The path makes a 4 degrees angle with the horizontal. The path makes 4 degrees with the horizontal. So this is 4 degrees. The path U, the point U on the path is 25 kilometers. So this distance is 25 kilometers. The top of the tower is fixed to U by a wire of length x meters. X. Complete the diagram. Show clearly all the information above. 25 meters. Then find the value of x. So x square equals to 25 square plus 36 square minus 2 times 25 times 36 times cosine. The remaining angle will be 86 because total angle is 90 degrees. So 4 degrees is already over. So cosine 86. From here, I get the value of x is 42.4. Question number 26. The diagram below shows a triangle ABD with AB equals to 13 centimeters, AD equals to 6.5 centimeters. The point C on the line BD such that BC equals to AC equals to 7. Find the size of angle ACB. This particular angle he is asking us to find it out. So cosine ACB equals to 7 square plus 7 square minus 13 square divided by 2 times 7 times 7. From here, I'll be getting the value of ACB is 136 degrees. Find the size of the angle CAD. So, angle ACD will be equals to 180 minus 136.4, which is nothing but what? I'm going to take it as this is 44, 44, 46, 43.6 degrees. Then this is 43.6. So I'm going to use sine rule. 6.5 upon sine 43.6 equals to 7 upon sine ADC. This gives me ADC equals to, direct answer I'm writing 47.9 degrees. Or you can write sine ADC equals to 7 times sine 43.6 divided by 65. Question number 27. The following diagram where BC is 105 meters, angle ACB is 40, ABC is 60. Find the area of the triangle. So The remaining angle will be 80. So I use sine rule. 105 divided by sine 80 equals to AB divided by sine 40. So AB equals to 68.533. So area will be equals to 1 upon 2 times 105 times 68.533 times sine 60. Simplify that, which will be giving 3116 meters. Question number 28. Find the two possible values of A, B, C. BC is 3, AB is 5, angle A is 30. So I use sine rule. So what is that sine rule for this one? 3 upon sine 30 equals to 5 upon sine C. So from there, sine C equals to 5 times sine 30 divided by 3, which gives me C value as 56.4 or 123.6. So B value will be 93.6 or 26.4. Question number 29. Find the area of a triangle. So first of all, I'm going to use sine rule. So which is sine 50 upon 8.71 equals to sine B upon 10.9. From here, I'll be getting the value of angle B. So sine B equals to 10.9 times sine 50 divided by 8.71. So we will be calculating the angle over here by doing sine inverse of 10.9 times sine 50 divided by 8.71. So this should be giving me the answer as which is 10.9 times sine 50 divided by 8.71. Which gives me B value as 73.5. But he says that it is an obtuse angle. So the B value should be nothing but what? 180 minus the answer, which should be giving me 106.5. So therefore, area of the triangle will be 1 upon 2 times 10.9 times 8.71 times sine C. What is sine C? If this is 106.5, sine C angle C will be 180 minus 50 minus 106.5. So 180 minus answer minus 50 should be giving me 23.5. So sine 23.5. Simplify that, you should be getting that answer 18.9 centimeters square. Question number 30. Triangle ABC. C is 42 degrees, BC is 1.74, area is 101.19. Find AC and AB. So this is A, B, C. C is 42 degrees, BC is 1.74, area is 1.19. So 1.19 equals to 1 upon 2 times 1.74 times sine 42 times AC. This gives me AC value 2.044 or 2.04. Next find AB. So AB equals to square root of 2.044 dot square, take full calculator display, plus 1.74 minus 2 times 1.74 times 2.044 and so on, cosine 42. Simplify that, you should be getting 1.39 centimeters. Question number 31. In the triangle, these are given, find the difference in the area between two possible triangles in ABC. So first of all, sine C upon 7 equals to sine 30 upon 5. This gives me sine C equals to 7 sine 30 upon 5. So C equals to 44.4 degrees, or 180 minus 44.4, which is 135.6. So B will be 105.6 or 14.4 degrees. So difference in the areas of the triangle. So 1 upon 2 times AC of sine B1 minus sine B2. So 1 upon 2 times 5 times 7 times sine 105.6 minus sine 14.4. Simplify that, 12.5 centimeters square. 32. In triangle ABC, angle ABC is 30, AB is 6, AC is 3 root 2. Find the possible areas of the triangle. So again, sine 30 divided by 3 root 2 equals to sine C divided by 6. This gives me sine C equals to 1 upon root 2. So C equals to either 45 degrees or 180 minus 45, 135 degrees. Now for this one, area is 1 upon 2 times 6 times 3 root 2 times. So we have to find the triangle A, B, C. This is 6, this is 3 root 2, this was 30, and C we found it as 45. So A will be 105. So sine 105. Simplify that, you should be getting 12.3. Now for this triangle A, B, C, 6, 3 root 2. So this is 30. This is 135. So this angle has to be 15. So area will be 1 upon 2 times 6 times 3 root 2 times sine 15, which is 3.29. That's going to be the answer. Question number 33. Triangle ABC. Find the possible lengths of BC. So sine C upon 6 equals to sine 30 upon 3 root 2. This gives me sine C equals to 1 upon root 2. This gives me C equals to either 45 degrees or 135 degrees. Now, if I take the triangle A, B, C, AB is 6, AC is 3 root 2, ABC is 30. We found it out C was 45. So this angle will be 105. In that case, 3 root 2 upon sine 30 equals to BC upon sine 105. This gives me BC value as 8.20. Now in the next triangle A, B, C, this is 6, this is 3 root 2, this is 30. The one we found it out was 135. So the other angle is going to be 15. So in that case, 3 root 2 upon sine 30 equals to BC upon sine 15. This gives me BC value as 2.20 centimeters. Now method B, use cosine rule. So AC square equals to 6 square plus BC square minus 2 times 6 times BC times cosine 30. So AC square is 18. 18 equals to 36 plus BC square minus 6 root 3 BC. Now this is a quadratic, or BC square minus 6 root 3 BC plus 18 equals to 0. So you can use the GDC to get two values of BC, which is 8.20 and 2.20 centimeters. Question number 34. In the triangle ABC, angle A is 35 degrees, BC is 4 centimeters, AC is 6.5. Find the possible values of A and corresponding values of AB. So sine 35 upon A 4, equals to sine B upon 6.5. So from here, sine B equals to 6.5 times sine 35 divided by 4. So that's going to be 0.932. This gives me B value as 68.8 degrees, or another value, possible values of B, 68.8 degrees or 111.2. Now for case 1, if at all it is 68.8 degrees, so angle C will be 180 minus 35 minus 68.8, which is nothing but what, 76.2. Then in that case, again I'm going to use sine rule. Sine 35 upon 4 equals to sine 76.2 divided by AB. This gives me the AB value as 6.77. Whereas if at all it is 111.2, then angle C will be 180 minus 35 minus 111.2, which is going to be 33.8. So sine 35 upon 4 equals to sine 33.8 divided by AB. This gives me AB value is 3.88. This is going to be the answer. So we completed 34 questions out of 52. The remaining questions will be done in the next video. Bye.